All right. Well, then I will turn off my video so that you can kind of focus just on the slides here. And yeah, nice to meet you, everybody. So my name is Addison. Today we're going to talk a little bit about Flink and Pulsar, the path to unified batch and streaming. Before we get started, I'll just give you a little bit of background about myself. So this is actually my second time speaking at Flink Forward. And my job title, I'm a software engineer / community manager at StreamNative. I've been doing these things for about 10 years now. Previously, I was a software architect at a company called Instructure, where I worked on the big data platform team. Did a lot of things with Spark, Flink, Kubernetes, Pulsar. So this is a place area of tech I love to work on, and I'm excited to talk to you about today. And if you want to talk to me, I've got some social channels here, GitHub, Twitter, but the best place to find me is the Apache Pulsar Slack, which I'll link at the end of the presentation. And where if you're interested, we'd love to kind of get some connect if you're interested in Pulsar. So as I mentioned, this is actually my second time speaking at Flink Forward. I spoke at Flink Forward 2019. And it's kind of an interesting path to Pulsar and to actually be speaking here again. So I spoke at Flink Forward 2019 about how we were using some low-level APIs in Flink to implement somewhat of a unified S3 Kinesis source. And then through that process, it worked fairly well, but was somewhat insufficient and for other reasons with using Kinesis. And so that led me on that team to explore Apache Pulsar and eventually deploying that system. And after doing that, the potential for Pulsar and the new capabilities there, also being able to do some really interesting things with Flink, that really convinced me to make it my next job. And so I'm really excited to kind of get to be here again to speak about Pulsar as a unified source for Flink and what we think why we're excited with that for both the Flink community and be able to use Pulsar. So just a quick outline of today's agenda. So I want to give you a short intro to Pulsar. Looking at the poll, it looks like, not a ton of experience with Pulsar. So we'll give a quick overview of what Pulsar is. We'll talk a little bit about why Flink and Pulsar work really well together, the benefits of using those two systems together. We'll talk about a little bit about the current state of the Flink and Pulsar integration, what the capabilities are. We'll talk about a company that's using Flink and Pulsar together, and give you an idea of where Pulsar is headed, particularly in its integration with Flink, and how you can be able to use those things together to do some really powerful things. So once again, short intro into Pulsar. So this is talking about Pulsar. I want to give just a quick overview of what we mean. This is the kind of the blurb that you'd see on the set website. Is Apache Pulsar is a cloud-native distributed messaging and streaming platform. By cloud native, one of the things that's really nice about Pulsar is it's learned a lot and kind of been developed in this massive shift towards cloud and elastic computing. And so Pulsar is really designed to run in these elastic environments and run across a variety of hardware. Likewise, it's a distributed system, much like many of these distributed data processing frameworks. It's a distributed system where there's no single point of failure, and multiple nodes exist, and you can horizontally scale. And this is where things kind of get a little interesting with Pulsar. Pulsar is a messaging platform, and we mean that more in the sense of traditional messaging, like pub/sub, other common messaging paradigms like work queues, all those things you might find in a system like RabbitMQ. But at the same time, Pulsar is also capable of supporting some of these newer streaming ideas, like low latency, long-term event capture and storage that's conceptually similar to Apache Kafka. So another way of putting that is we see Pulsar as a next generation streaming platform that offers what we call a unified messaging model that gives you both the best of traditional messaging needs like pub/sub and all these application messaging use cases that you're probably familiar with, as well as being able to operate in the world of event streaming and to be able to power some of these larger sophisticated use cases with the Flink offers. A quick background on history. So Apache Pulsar was developed at Yahoo, now Verizon Media, and it was open source in 2016 and a top-level Apache project in 2018. The original use case around that was to be able to replace a lot of JMS workloads while also being able to do longer retention and whatnot, and to be much more operationally simple. So since then, it's been adopted by a lot of companies and continues to see a rapid adoption, like Tencent, Yahoo Japan, Nutanix, etc. And Stream Native, the company I work for, we started in 2019. We have some of the original maintainers of both a Pulsar and Bookkeeper, which is one of the companion projects to Pulsar. And we continue to have more maintainers and PMMC members on the project. So quick overview of the features. Once again, we already sort of mentioned this idea of a unified messaging model, where Pulsar really aims to be able to support these traditional messaging use cases, pub sub work queues, as well as to act as an event streaming, an event storage and stream platform. That includes things, reader controlled offsets, long-term event storage, all in sort of one system. But beyond that, Pulsar intends to be a really easy to operate system. If you're familiar with Apache Kafka, there's things you may have to do with that, with like rebalancing your cluster in the event of startup or from a failure, or adding new nodes. Pulsar kind of makes that process all be automatic. That's seamless, and there's no need to rebalance. It offers high throughput and low latency. It's highly durable and consistent, and also offers multi-tenancy, geo-replication, tiered storage to S3, and honestly a lot of other features that we'll kind of try and talk through this. But that gives you maybe a high-level overview of the biggest selling points of what Pulsar is trying to offer. And throughout this topic, or throughout this talk, we'll refer to some of these sort of primitives that exist within Pulsar. And so just want to give sort of quick definitions of those. Like many messaging systems, Pulsar has a concept of producers and consumers that are used to send and receive messages, and a broker which actually handles those messages, routes messages, connections, etc. Similar to other messaging systems, there's also a concept of a topic. And in Pulsar, topics are identified by a structured URL-like structure that represents some of the entities in Pulsar that are used for multi-tenancy. As you can see here, there's the tenant namespace and the actual topic form that fully qualified topic name. Like other messaging systems, Pulsar can have a key and a value, and can have that value. The key of that can be is an optional key that allows for you to use partition topics, which allow you to scale out a single topic across multiple underlying topics, and to scale out your read and write capability on your cluster. And as mentioned, this tenants and namespaces, they're a hierarchical organizational structure that allows you to provide multi-tenancy. So as well as, and that includes details of isolation, security, and mapping well to sort of your organizational structure in different teams. And once again, if there are questions, feel free to leave them in that Q&A section. I'll be happy to take a look at those and answer some of those as we go through. But so that's the really high level overview of what Pulsar is. And so let's talk a little bit about why Flink and Pulsar is a compelling offering, and why you might be interested in it. So as Stephen mentioned today in his keynote, Flink is rapidly moving towards and really trying to focus on improvements in Flink to allow it to kind of achieve that ideal of unified batch and streaming, where we can have a single workflow, a single job that can read a whole bunch of backfill historical data in batch with a high throughput, and then seamlessly transition into a sort of a streaming idea of grabbing the most recent data and keeping things up to date. And Flink has made a lot of progress in making that be a reality, but there's still some needs on the integration side, on the sources and the sync side, particularly on sources, to be able to feed those sort of workloads, and to be able to offer that batch capability and the streaming capability in sort of in a nice cohesive way. And beyond that, one of the things that, if you've run Flink, if you've tried to deploy that in an organization, recognize that there's a lot of other needs to really make effective use of Flink, to get kind of that comprehensive data strategy, to really realize that a vision of unified view of data in both batch and streaming. So Pulsar is aimed to help meet some of those needs, and is designed to help have that flexibility. So we'll talk about this more, but Pulsar offers a tiered storage, has a tiered storage architecture. So native to its design is the ability to take chunks of messages, offload those into some other storage, and then be able to expose the metadata needed to a system like Flink that it can read that data in batch, and then seamlessly transition to the streaming capabilities of Pulsar. And beyond that, those capabilities, Pulsar also offers a lot of feature set to help you really meet the demands to sort of be that way of how you transport data across your organization, so that you can then use Flink to really answer and do interesting things with that data. And so we really see those two pieces together as being a very powerful capability that exists within an organization to really meet your data goals. So as we mentioned, Pulsar sort of does stream storage differently. If you've used other streaming systems, Kinesis, Kafka, Pulsar operates in a similar way, but offers additional flexibility in its storage model. And once again, that kind of gets to this idea of being able to do not only that storage offloading for batched reads, but also for cost-effective infinite retention. As you're moving towards a unified batch and stream model, you need a stream storage engine that can allow you to actually store those streams effectively for long periods of time, potentially infinite periods of time. So we'll talk a little bit now about Pulsar's architecture, how it enables that. So in Pulsar, there's three main components. Pulsar itself offers what's a broker, and that's what actually handles the connections and move the messages. But Pulsar, where it differs from other streaming engines or stream storage engines, is that it offloads the storage in a separate layer, in this case, Apache Bookkeeper, and that takes care of the actual message persistence. And then both those systems use Zookeeper for doing things like consistent metadata, leader election, etc. Just to give kind of a lines and boxes here with that. So producers and consumers only interact with brokers, and the brokers then communicate with the bookie tier to be able to, which is the bookkeeper component, to be able to store those messages. And then both those systems use Zookeeper for storing that data. And as we mentioned, the way that Pulsar is able to have some of those advantages on the storage side is part of the details of how Bookkeeper stores data. So for here in this diagram, we have a view of a topic that's split that has 4 different partitions. Over time, those partitions, one after another, we're open to a single segment at a time. And then once that segment's closed, it's sealed and not used, and a new segment will be opened. And so once these segments are closed, we can actually move them off to different storage subsystems and then have Pulsar be able to read directly from that, which we'll talk about more. So as mentioned in talking about these topics and segments, this is how that kind of maps to those different tiers. An individual topic or topic partition will be mapped to a broker, and then that broker will save those messages in segments on the bookies. And then once those segments are closed, those segments can be offloaded onto tiered storage like S3, Google Cloud Storage, Microsoft Azure Blob Storage. And then the brokers can then read those segments directly from the tiered storage, excuse me. I think there was one question there that I just saw pop up, but it may have gone away. So start with things like dependencies, like things like Zookeeper. And this is a question I'll get to. We can talk about that, Austin, a little bit later. Asking a question about the dependency on Zookeeper and having to run that, and being able to do away with the Zookeeper dependency. That is something that we're working on, and I'm happy to talk with you a little bit more details about that offline. So once again, kind of to recap this, Pulsar's streaming API offers kind of high throughput, long retention, and meets all the availability needs that you kind of require out of a stream storage engine. But it also offers the ability to have other ways of viewing that storage with the segment-based storage, allowing you to offload that storage and then also support the sort of those batch reading use cases. And that's once again really how we see Pulsar being a really great fit to be able to support a Flink job that does that seamless transition from a backfilling job to transition with high performance and throughput. Excuse me. And then once again to that second point here, about needing more than just to really leverage Flink and to leverage those capabilities, there's also more things you have to worry about in your organization to fully leverage Flink and Pulsar to meet kind of your data needs. And one of those things that we see is really important gets back to that idea of Pulsar being to act both as a traditional messaging system as well as a event streaming platform. And so what we mean by that is, I'll move to this next slide here. Oftentimes you have application teams that have a different set of needs from maybe what your data analytics team's needs are. Application teams, they want to use something that's very easy to integrate, is maybe very easy to do some of their work queues, send events to PubSub for applications for basic application communication. They may not want to worry about all the details of having to figure out how many partitions is needed for a given application, and about the differences of ordering concerns and whatnot. And so Pulsar offers an API that really can meet the needs of both sort of sides of your organization in that way. And the way it does that is through its concepts of subscriptions that allow you to have different semantics around how you consume and use data in Pulsar to meet sort of those different demands. So to kind of go quickly through some of these, so Pulsar offers 4 different subscription types. The first 2, exclusive and failover, these 2 subscription types offer an ordered, give you guarantees about the order you're going to see your messages. And so they're really kind of a great way to be able to have, in many evented use cases, of being able to sort of preserve that order and go through that topic one message at a time and do sort of the processing you need. But it can do that in a very high throughput manner by optimizing how those messages get sent and then how you acknowledge those messages back to the broker. But it also can support use cases where you need to treat it more like a work queue, where you don't care as much about order, but you want to be able to distribute that work to a lot of different consumers at once. And so that's what the shared subscription offers. And then finally, there's the key shared subscription, which really is a powerful feature for allowing you to, once again, to not have to worry so much about the number of partitions you have. You can guarantee order on a single key, and that's so a given key, that same key will always be routed to the same consumer. And that really allows you to have a couple of partitions that you can then farm out the work to more consumers and sort of work through that work much faster. And so that's what exists kind of on the application side. And I just want to give a quick example of what this API looks like in practice. So we can build a Pulsar client. It's a fairly straightforward sort of builder pattern. This is the Java API. And sending a message is as easy as just sort of a PubSub style. I'm going to create a producer. It's going to produce to one of these given topics, and I can just send that message. And then on the receiving a message, once again, using sort of those PubSub semantics, I simply give it the name of a topic, the type of subscription I want to use. In this case, we're using an exclusive subscription that will give us those ordering guarantees. And then I simply receive and then acknowledge those messages. So it's a really nice and easy to use API that integrates well with in applications, makes it easier for you to get your teams to use this messaging technology. But the great part is that once your teams are then using Pulsar, even if they start for just very basic application needs, it can still support some of these more advanced use cases like Flink, with being able to have really sophisticated processing of the stream. And the Reader API is the API which we use in Pulsar to support that. The Reader API is more similar to something like Kafka Kinesis, where the reader controls the positions within the stream. And so by supporting both these APIs, that's one of the ways in which Pulsar can really help meet the needs of all the different sides of your organization, all the different use cases you might have for messaging. And so once again, to kind of recap this, there's sort of this idea that we see in Pulsar of being able to sort of converge on a single messaging solution. And the reason that's really powerful is if you have multiple different messaging systems that are being used for different things, it often leads to this data silos where different data is locked up in different systems and is not easily accessible to your processing engines like Flink. Many organizations may find themselves in this situation, and they'll use workarounds like replicating data between systems, and that becomes error prone and expensive. So by Pulsar offering a really flexible API that supports all these different use cases, it really helps to break down those data silos and get all of your data in one system that you can then really successfully access with Flink. And beyond just having that API, Pulsar also offers a lot more than just the messaging side of the solution. It also includes things like a schema registry that's built into the system, which helps you do validation and all those different things. It also offers options for multi-tenancy that helps you have hierarchical structures in your organization and policies that help to control the usage of your cluster to make sure that you can truly have like one cluster that can support many different needs. And then for those needs where you really do need to go beyond maybe one cluster, it has federated management and things like georeplication for replication across different regions. All right, that was a lot there. I don't see any other questions. Maybe I'll pause for 1 second and see if there's any other questions. All right, I don't see any popping in. So we'll talk a little bit about the current state of Flink and Pulsar, what you can do with that today. So Stream Native maintains a Pulsar Flink connector found at this GitHub URL there. It has support for Flink 190 and higher. It offers both a source and a sink, the ability to subscribe to multiple topics, either via list or regex, control parallelism, all these really things you would expect. But it also has the support, for our shared key or key shared subscriptions, which gives it the ability to have a lot more flexible model. So I don't know if you've used a system like Kinesis or Kafka, there are times where if you can't get your data out, if you have an expensive Flink job and you only have a few number of partitions, that can sort of limit the parallelism you can have on that job. With Pulsar, because of its key shared model, you can actually use that to have more consumers than you have partitions or shards in the case of Kinesis. And so it can help you to have a more flexible way of reading that data out. It also has support for the Flink table API and the SQL API, and it's integrated. The Pulsar schema registry is integrated with the Flink catalog to allow you to do sort of the serialization there. Has exactly once source support, timestamp extraction, and many other features, support for many other things sort of within the integration. Talking a little bit, we touched on this a little bit. The connector internals is built on that Reader API, where the Flink is owning the state for that subscription and the position in it. But along with that, it actually also creates a subscription in Pulsar and keeps that subscription relatively in sync with where the process is. So you can actually, if you for some reason are unable to have a save point, you can actually resume your job from a subscription or start your job from a given position by using an existing subscription in Pulsar, and then Pulsar or Flink will then use that subscription as to know where to start from. It does topic discovery and can dynamically add new partitions as they're added. And so that's all taken care of as well. And as I mentioned, it can also use that key shared functionality to have more readers than partitions, which can really help in certain use cases. So I want to highlight real quick, this isn't just theoretical. People are using this just to kind of give you an idea of Pulsar in itself. Pulsar is seeing rapid adoption from a lot of companies, include companies like Tencent, Splunk, the company I worked for, Instructure, OVH Cloud. A lot of companies are looking at Pulsar and finding a lot of value in it. But we wanted to highlight today one company who is using both Flink and Pulsar together very successfully. So if you aren't familiar, BIGO is a company based out of Singapore that does short form video and live streaming. And their Pulsar cluster has ingest rates of more than 2 to 3 gigabytes per second and have millions of messages a day. So BIGO initially went with Pulsar because they were spending a lot of time managing and maintaining Kafka clusters, and they liked Pulsar's ability to kind of give them easier management and the ability to have more of their workloads map onto one cluster through some of the isolation capabilities and reliable latency that it still offers. So they began adopting Pulsar in November of 2019 and had their first production app in May of 2020. And one of the important things for BIGO, along with, on the Kafka side, was a really good integration with Flink. And so BIGO uses Flink for a number of their workloads, like real-time data warehousing, ETL, real-time analytic, or real-time recommendation engines, and they use that they read from Pulsar and then output to other systems, as well as writing out back to Pulsar. And that, once again, that Flink integration was really critical to their success. And so they also used Flink SQL. They contributed the Flink SQL support to the Flink connector, to the Pulsar connector. And made some other contributions, and they've used it successfully in production. And they continue to see more adoption of Pulsar as it continues to grow in their organization. Once again, Flink has a lot of capabilities that are not yet well unlocked by many of the Pulsar, or by many of the integrations with Flink. And so we're going to talk about where Pulsar is headed, and more specifically, where Pulsar is headed in terms of its integration with Flink. So we really have a goal, which is to support all of Flink's capabilities, including unified batch and streaming with a single source, end-to-end exactly once processing. So you're able to have a message read from Pulsar and then published to another job with guarantees around only having exactly one copy of it. Obviously, really high performance, particularly in those batch workloads, and it's robust support for the schema and table SQL API support. And once again, I think maybe you can now see that due to Pulsar's ability to support batch workloads with being able to read off tiered storage, that's one of the things we're really focusing on, is being able to have be very optimized for that use case of batch and streaming together. But beyond just batch, there's also other concerns when being able to talk about a really optimized system. So one of the great things about Pulsar is that it also, when you're doing some of these catch-up and backfilling operations that may be that aren't necessarily coming from the batch support, right? Even if you still need to replay the last 30 minutes or something, Pulsar does a really good job of ensuring that doesn't affect your write performance. If you increase your read performance, it won't, or if your read load, it won't impact your write performance. As we already talked about, the offloaded storage allows for batch capabilities, and Pulsar actually does support, just recently was merged, support right now for using the dataset API. And the Flip 27, the new source API that was recently merged, I think Steven talked about, the work is ongoing right now to refactor our source to use that, and that's where we'll really start to be able to use the unify the batch and streaming capabilities. And that work you'll start seeing ongoing in the open source community. And as I sort of mentioned, there's other sides to this rather than just the unified batch and streaming. Transaction support is landing in Pulsar 2.7, and soon after, support will land in the connector to allow you to have the exactly once sync as well. We're also really focused about being able to do improved event time handling, like event time alignment that allows you to not have to worry about less out of orderness happening from your different partitions. That's something that we'll be adding with the refactor to the new source API. And then one more very exciting thing is that Pulsar is going to be working towards columnar offloading, to offload those closed segments and transform them into a columnar format. And with that, we'll be able to offer performance using the table API, where it can do things like predicate pushdown and pruning to give you really great batch performance when reading data off of Pulsar. And one of the big things that we're excited about is to be able to work more closely with the Flink open source community and we're targeting to get the Pulsar connector upstreamed into mainline Flink, likely into Flink 113, which will be using that new source API. So if you're interested in Pulsar, if this has piqued your interest at all, we'd encourage you to visit the website. We also, as I mentioned, we have a Slack community that's very active, has over 2,000 members in it. Encourage you to go join that. And then if you want to get some more information about both Pulsar, its internals, who's using it. We recently had a Pulsar Summit conference, which you can find the talks and the events that were here. And we'd love to be able to chat also if you have any questions about that, please come to the Slack community. And one more thing is StreamNative has a Pulsar offering, and details are here if you want to get started with it that way. I think that's it. If there's any, I don't know how much time we have for questions, but happy to answer any questions.